Okay, good afternoon, everyone. Again, my name is Denise Molinax, and I'm the Director for the California Dairy Research Foundation. This afternoon, I'd like to welcome you to the first of two research poster video Q&A sessions. So as part of the summit, CDRF offered researchers working in the area of environmental posters or 3-minute videos on their research. We received several submittals and chose 12 to highlight during the summit. So this session will really focus on the poster videos in the area of manure handling and use and cow feeding. And we'll provide you with an opportunity to really ask questions of the researchers regarding their work. So first, I'll introduce you to our presenters quickly. But really, I want to allow each one of them to give a 1 to 2 minute overview of their project, and then open it up for questions from you. So the participants in this presentation include Anthony Fulford with UC Cooperative Extension, Hazen Adoleti with University of California, Davis, Nicholas Clark with UC Cooperative Extension, Joy Hollingsworth with UC A&R, Jennifer Hagy with UC Cooperative Extension, and Scott Somerville with University of California, Davis. So Anthony, we'll start with you and let you give us a 1 to 2 minute overview of your research project, if you will.
Thank you very much, Denise. Yeah, so as Denise mentioned, my name is Anthony Fulford. I'm a nutrient management soil quality farm advisor here with the University of California Cooperative Extension. And I put together a 3-minute kind of video entitled the seasonal nutrient composition of compost bedded pack and vacuum scraped dairy manure. So really this project was motivated by the fact that we view this manure as an input for subsequent downstream processing. In this case, this includes drying and composting prior to the land application of those manure solids. So with this project, we really wanted to understand the seasonal changes in that manure composition to help dairies really more efficiently use those nutrients both on farm and off farm. So with this project, it started in 2020, and we sampled manure from these two different management systems in both the summer and winter months. So in terms of the results that we found for the compost bedded pack barns that we sampled, they tended to have a similar nutrient composition between seasons, indicating that they would have be expected to have a similar fertilizer value in the compost for both the winter and summer months. When we looked at the results that we were getting from the vacuum systems, we noticed there was a tendency for the nutrient content of this vacuum scraped manure to be greater, have a greater nutrient content in the winter compared to the summer. And as a result, we expect that fertilizer value of that vacuum scraped manure to be noticeably different when we look at this change based on seasonality. So, however, with the high moisture content or with the moisture content of these manures, especially from those vacuum systems, it suggests that we really need to be looking at additional sampling after any of this subsequent processing occurs. So the drying or composting, after that's done, we really want to take another sample as close to the time of land application as possible in order to really get that best representation of the fertilizer value of that land applied manure solids. So that's kind of the brief overview of the 3-minute video that I put together. And yeah, I really thank you for inviting me to this session. I look forward to the questions and discussion. Thank you.
Thank you, Anthony. Now we'll move to Hazen. Hazen, if you could give us a quick overview of your project as well.
Hi, Denise. Thank you. My name is Hazen Adoleti. I'm a PhD student in the Department of Bio and Agricultural Engineering at UC Davis. I'm advised by Professor Rahung Zhang, and my poster presents a collaborative project funded by the CDFA, the California Dairy Research Foundation, and the Almond Board of California on the production and application of compost products from dairy manure and almond waste as soil amendment on California almond orchards. The two top ag industries in the state are the dairy and almond industries. Both industries face challenges, and in terms of the dairy industry, dairies produce a lot of manure in a small area, contributing to 25% of California's methane emissions. And then looking at the almond industry, on average, 13% of the harvest brought into almond processing facilities is field debris like sticks and twigs, rocks, dirt, and the sticks and twigs specifically present challenges. They don't have much value, and they present these facilities with challenges. So we're looking at a potential solution, and the goal of this project, which is to recycle that dairy manure and the almond stick and twig waste back on orchards as a soil amendment in the form of loose and pelletized compost products, to create like a sort of almond dairy loop, if you will. The industries have a history of working together fairly well, and geographically they overlap. Ultimately, dairies need to export manure sustainably, economically, and generate revenue streams. And almond orchards need organic matter amendments to build healthy soils. So, and as a society, we need to reduce our GHG emissions and sequester carbon. So, if you look at the project, we took dairy manure mixed with almond sticks and twigs, and we created compost products from both of those. We took some of the loose compost and we pelletized them to create the pelletized equivalents using a flat die pellet mill. And these 4 treatments, in addition to a no amendment control, were tested in a commercial almond orchard.
Very good. Thank you, Hazen. Nick, same question for you.
Thanks, Denise. I'm Nick Clark. I'm the Nutrient Management and Agronomy Farm Advisor in the Southern San Joaquin Valley for the University of California Cooperative Extension. I presented some partial results from a collaborative research project funded by the California Dairy Research Foundation. 2 of my other colleagues are here. Anthony Fulford, you already heard from, and Joy Hollingsworth, you will hear from. I just reported on some sampling and analysis we did of settled solids in a lagoon after it was drained, because we had the opportunity to do it during this project. So we have some chemical and some physical analyses of that manure, not often reported, and we're happy to share that. Thanks.
Great. Thank you, Nick. Joy, I know you also participated in this project. Could you talk to us a little bit about your presentation and the portions you presented?
Yeah. Hi, everyone. My name is Joy Hollingsworth, and I am a UC Cooperative Extension Farm Advisor for Soil Quality and Nutrient Management. I cover the South Valley, so I'm Anthony's counterpart in Fresno, Madera, Kings, and Tulare counties. And as Nick mentioned, and Denise also, my video was about a California Dairy Research Foundation funded project that looked at various physical and chemical properties of manure from dairies using various treatment technologies. I focused on the anaerobic digesters in my video. The main takeaway from the digesters was that the effluent coming out of the digesters was much more concentrated in terms of solids and nutrients in the wintertime than in the summertime. And this tells us you're going to want to blend your effluent with fresh water before applying it to your fields to avoid the over-application of nutrients. We also saw relatively high levels of salinity in our readings, and so even in the summer samples, which again were a little bit lower. So this is another important reason to consider diluting the effluent.
Thank you, Joy. Now we'll move on to Jennifer Hagy. Jennifer, could you give us an overview of the project that you presented?
Hi, good afternoon. Thank you, Denise. Again, my name is Jennifer Hagy, and I am a dairy farm advisor with the University of California Cooperative Extension in the northern San Joaquin Valley, and I also serve as the director of extension in Stanislaus County. Today, or this week, I presented some information on almond hull feeding rates and practices from a survey that we conducted in early 2019. And this work was done to inform a larger project funded by the Almond Board of California to evaluate increased feeding rates of almond hulls on California dairies. So just some highlights: 41% of nutritionists reported an increase in their almond hull usage over the previous 5 years. On average, nutritionists were incorporating almond hulls at a rate of 5 pounds per cow per day in lactating cow rations, with a range of 1 to 10 pounds. The highest fed herd reported that at 18 pounds per cow per day of almond hulls in the lactating cow ration. And so these feeding amounts indicate a potential opportunity to increase almond hull feeding rates across the state. The biggest concern nutritionists have when feeding hulls pertain to quality issues, specifically that stick and shell that was previously mentioned. And just a plug, we have reported the results on all this almond hull work extensively in our California Golden State Dairy newsletter. And so if you're interested in any of that, you can reach out and I'll make sure to get you all that information and get you signed up for future editions of the newsletter. Thank you.
Great. Thank you, Jennifer. And lastly, let's move to Scott. Scott, could you give us a brief overview of the project that you presented?
Yes, Denise. Hello, everybody. I'm Scott Somerville, originally from Scotland, now at UC Davis working towards my PhD in agricultural economics. Together with the co-authors, we presented the poster titled The Economics of Byproduct Use in Dairy Feed Rations, including resource consequences. And in the poster, we focus on 3 byproducts that are of interest to California and US dairy, including almond hulls, canola meal, cottonseed, and the cottonseed meal and hulls. And in our research, we're really interested in knowing the extent to which dairy demand for byproduct feeds affects the resource use in crop production. And we used an economic model to simulate what would happen if the quantity of almonds, what would happen to the quantity of almonds produced and the prices if dairies bought fewer tons of hulls, for example. And we also done similar modelling for the canola and the cotton industries. And we find that the acres of the crops like almonds, canola and cotton would change a little bit, but not very much. And instead, many, many more acres of crops like corn, silage or hay, these non-byproduct feeds would have to be grown to replace the nutrition that's supplied by byproducts if we wanted to maintain current milk production.
Thank you, Scott. And a huge thank you to all of you for the work that you're doing and for being here with us this afternoon and providing us with an overview of your projects. So now we'll move into the open dialogue portion of our session. And I have received a few questions, but if folks want to keep them coming, just remember to put your questions in the chat. So the first question is actually for Joy. And Joy, the question is, on average, how did the digester effluent compare to the effluent from non-digester dairies? Are there any specific recommendations you have for producers that maybe have like recently installed a digester with respect to applying their nutrients?
Yeah, thanks, Denise. So I think the first thing I should point out is the effluent coming out of the digesters was highly variable. You don't always know what you're going to get. So I said before that the clearest trend that we saw was much higher concentrations in the winter than in the summer. But if you noticed on my video, I had a slide where I showed the ranges in the summer and winter, and even within the season, it was still pretty highly variable. So the closest comparison to a non-digester effluent would probably be pond water. And there's been some previous work done on looking at pond water by Pettigrove and Heinrich, and also by Dan Meyer. And I was looking at that data. I found that their pond water was also very highly variable. The closest I saw the salinity levels that they found were that Pettigrove found were pretty similar to what we saw in our effluent. But all the other nutrients were definitely. There was a pretty big range. So I think it's hard to say. Another thing that I found was that looking at Deanne's work on the lagoon water, it really makes a difference where you're pulling from. In different areas of the pond and at different depths, it changed dramatically what sort of nutrient levels they were getting. So for a producer recommendation, I'd say again, the importance of blending your effluent with some fresh water before you're planting to fields, especially in the winter when the concentrations were much higher. And this is especially true for salinity levels. So you really want to be careful because you can cause salt injury to your crop.
Great. Thank you. Anthony, the next question is for you. In your video, you talked a lot about the importance of monitoring moisture in the bedded pack barn. How frequently would you recommend sampling the bedded pack for moisture?
Question really gets at this point of the ways that we're able to manage the compost in these bedded pack barns. So with one of our best management tools with these compost bedded pack barns is frequent tillage. So we're aerating that compost bedded pack. to really get oxygen into that manure, into that bedding, to really help kind of stimulate the compost, the active composting of that manure that's in that bedded pack. So with the actively managed compost bedded pack barns, are really tilling quite frequently. So with that tillage, gives you an opportunity to observe the moisture content of that pack without necessarily sampling it. So in conditions that are, where the bedded pack is really dry, you can see just by tillage, you're creating a lot of dust in that bedded pack. So that already indicates that compost is really too dry, or is really very dry. And on the other end of that, there's conditions where the bedded pack is really wet, and you can also see that from your tillage management. You won't be able to till that bedded pack very effectively. So both of these things can be done without really necessarily even sampling the compost bedded pack. So those are kind of visual clues. But in terms of actually sampling, if you want to sample and send it to a lab to get that compost kind of analyzed for moisture content, probably from our research, we really would suggest sampling that annually, and then keeping it consistent within season. So if you're consistently sampling in the summer, it's a good idea to continue to sample in the summer, send those samples to a lab and have that analyzed for moisture content. That'll give you a good idea of kind of the consistency of that moisture throughout the season and over years. And then of course, for a recommendation, anytime you're changing the management practice, you want to sample again. So if you're adding different carbon additions to that bedded pack, if you add more bedding than you normally would, you definitely want to go ahead and sample that bedded pack again for moisture content, because those carbon additions will adjust that moisture. Anytime you're changing management, it's another good time to go ahead and sample that compost bedded pack for moisture content.
Thank you, Anthony. And before we go on to our next question, we got a text in the chat that there's quite a bit of feedback. So if the speakers, since there's a lot of us in the panel, perhaps if you could mute yourself if you're not speaking, that will help that. We did get another question, and this one is for Jennifer. Jennifer, you shared average whole feeding rates as well as high and low. Did you calculate the median feeding rate, and what was it? Did you get an indication that if some of the quality issues could be addressed, that more nutritionists would recommend including holes in the rations?
Sure, thank you, Denise. So actually, median was the same as the mean, so it was 5 pounds, which means half above and half below 5 pounds. The mean was interesting just because in 2012 there was another survey done, and it showed from 2019 that we've increased almond whole feeding rates by about 1.5 pounds per cow per day to those lactating. For the quality issues, from both this survey and then additional byproduct survey work that we've done with dairy producers, we know that a lot of folks are feeding almond hulls. It's one of the most commonly found byproducts on dairies. So I think as the quality issues are resolved, there's an opportunity to increase the feeding rates of hulls, because as we get that debris, the sticks, shell, dirt, they decrease the feeding value. So increasing getting those higher levels of hulls in rations, you really aren't going to do that with that decreased feeding level. So again, I think quality comes into how much do we feed versus do we feed it at all. And then of course pricing is also going to contribute to that discussion of how much almond hull we put in a ration.
Yes, it will. Okay, thank you. Our next question is actually for Scott. Scott, can you talk a little bit more about the relationship of almond hull production versus use? Your presentation seemed to indicate that if dairies didn't use the almonds, that almond growers would produce less. Can you kind of clarify the relationship there and the price effects?
Yes, and I think it's best described with an example of our economic model simulation, which is that we simulated a 10% reduction in the quantity of hulls used by dairies, and that's equivalent to about 170,000 tonnes of dry matter from hulls. It's completely critical, but we want to see, knowing what we know about other parts of the industry, where else hulls go and how we expect producers to respond, what might be some effects of that. And well, we expect that the price would drop of hulls, the hull price would drop, and over about 10 years, a long-term horizon, other users would use some more hulls. That could be other livestock industries in the US, or some hulls might be shipped out of the US. And because hulls are about 4% of the almond industry revenue, according to our calculations, the revenue to the almond industry would drop by about 0.5%, given that 10% reduction in quantity used by dairies. And the growers would respond to that decrease in revenue, we expect, by growing about 3,000 fewer acres of almonds if everything else remained constant. But of course, bearing acreage has been trending upwards for a long time now. And really, towards the end of our modelling exercise, what we do is we say, if we maintain milk production at current levels, what resources would be needed to produce that dry matter, at least the dry matter, you never mind, the protein and energy and everything else that's required to maintain milk production. And well, the fact is there would be a huge increase in corn silage acreage. For example, there would be 18,000 acres of additional corn silage required just to meet that dry matter need. So it's a huge increase in resources for land, for example, to produce the dry matter, given a small decrease in the almond acreage, 3,000 acres on the other end.
Sorry, had to get off of mute. Okay, another question came in for you, Jennifer, and that is, how does the quality of the hulls impact their nutritional value?
Sure, I'm having mute problems as well. Sure, so as the debris or the sticks, the shell, the dirt, those are going, when those are included in the almond hull deliveries, those are going to decrease the sugar and energy content of the hulls while increasing the fiber. So basically, you're just diluting, the hulls with these low or non-digestible components, thus decreasing your feeding value of the hulls. So debris increases fiber while decreasing the sugar and energy content of the hulls. And just a plug, so Ed DePeters did a lot of this work at UC Davis as part of that larger grant. And because I'm shameless, I will plug the newsletter again. We have all of these studies are summarized with all that data. We have some violation data, but all summarized in the Golden State Dairy Management newsletter. And you can find all that information there.
Okay, Jennifer, thank you so much for that. Nick, I don't think we've asked a question of you yet, so here's one for you. It looks like the research indicated that the various materials would make good feedstock for composting. What would you recommend adding to create a good quality compost product for land application?
That's a good question. Two things to note about the sludge settle that we sampled. It's very wet, and it had a low carbon to nitrogen ratio, meaning with regard to nitrogen mineralization or decomposition to yield a net increase in plant available nitrogen. It was hot. So when I say wet, we're talking about 75% moisture in this material. It's kind of like sampling tar. For an ideal compost pile for rapid aerobic decomposition, you'd want between 50 and 60% total moisture. So right away, something drier. You want to add something dry to it. The carbon to nitrogen ratio that we found in this material was about 8.3. So for every pound of, or for every 8.3 pounds of carbon, we were finding 1 pound of nitrogen. Most of that was organic nitrogen, but at that carbon to nitrogen ratio, it probably would not stay that way if left to its own devices. An ideal carbon to nitrogen ratio for rapid composting is between 25 and 30. You might go as low as 20 or as high as 40, but you want to narrow that range to 25 to 30, where it's just below stable. So now to talk specifically about materials, probably heard a lot about some of this stuff. You know, Jennifer was mentioning the things that you don't want in your almond holes. Almond shells, for instance, is something that we find going into some compost feeds. There's a lot of wood chips that are coming off of recycled orchards. There's certainly a lot of research on what the soil benefits are to incorporating that, but you know, with more composting coming online, that might be another ingredient to throw in there to dry it up and add some carbon. Rice hulls certainly is a popular dry and carbon-rich material. So in this respect, we, just in summary, we want to add more carbon-rich materials and add lower moisture materials to bring down that total moisture and raise up the total carbon to make it a more stable product with respect to net nitrogen mineralization, and to encourage aerobic decomposition as opposed to anaerobic decomposition.
Great. Thank you so much for that. I think that brings us almost to the end of our time. So I really want to thank all of you for spending some time this afternoon and being willing to rain some questions from the group. And we also very much want to thank the audience for your participation and submitting great questions. So with that, I think we have a short pause, and then we're going to go into the second session of our poster Q&A sessions, which my colleague, Dr. Kevin Comerford, will be monitoring. Thank you all for joining us.